In this video, I'm going to show you why this call out and this call out mean different things. So in kind of a literal sense, 2 by 45 degrees, if you plot that out in a triangle, the other side is 2 inches, right? 2 by 2, you would have a triangle of, with 2 2-inch legs. With drawings, though, we have tolerances on every dimension. So whether it's a basic dimension that has a geometric tolerance or a plus or minus dimension, or even a thread that goes to a thread standard with tolerances, there's always got to be a tolerance, even if it's a chamfer, you think is an unimportant feature. So over here, I've switched to customary units, a 1-inch by 1-inch chamfer, so I've called this out with a note. Here we've got a 1-inch by 45 degree chamfer, and I'm going to show you why they're different. We have a general tolerance here, 2 decimal places plus or minus 20 thousandths, with angles plus or minus 1 degree. I didn't mention it a second ago. This is figure 4-41 from ASME Y14.5-2018 that shows something very, very similar to this. So for our 1 by 1 or linear by linear, our minimum is going to be 0.98 by 0.98, maximum 1.02 by 1.02. So in each leg, we can get anywhere between those. So generally what we would be looking for if it's an external feature, which most chamfers are. So think about, the chamfer around a pin or a shaft or something. What's generally going to cause a problem is this lower number, because that would tend to make an interference. So if we had, something with a fillet or a round, we want to make sure that the chamfer is going to clear our fillet or our round. So with the radius, we want to make sure the radius is smaller than the shortest leg of our chamfer. So if you have a radius of, say, 60 thousandths, the shortest leg of our chamfer must be larger than 60 thousandths, or we might run into an interference. I said we can get any combination of these, right? 0.98 by 0.98 would be the worst case for a situation like this. We'd have to make sure our radius was no larger than 0.98. Now, the real question here, we've got this call out 1 by 45 degrees. We're saying plus or minus 1 degree, so this angle can be anywhere between 44 and 46 degrees, and the one leg can be anywhere between 0.98 and 1.02. So the question is, what's our worst case here? And that's going to be when this leg is its shortest. Now we could solve this for all 4 combinations, but you can, I guess, just trust me. We want to look at what makes this angle smaller and then what makes this size smaller, because that's going to result in the chamfer being smaller and more likely to interfere in a situation like this. So quick trigonometry, we want to know what this side is. We have this angle, so it's going to be opposite over adjacent, so we're going to use the tan function. Tangent of 44 degrees times this short leg is going to give us 0.9463. Okay? That's much smaller than this 0.98 degrees, right? A good amount smaller as far as these things go. Now here's the thing, without anything else, you would need to consider both legs this size, right, for a worst case analysis, because we can't know from here which one the inspector is going to consider the angle side. So they could do this formula from this corner and make this the short side. Now there's ways around that. We can use the dimension origin symbol to indicate exactly which side the angle comes from. So you would only have one leg that has this 0.9463, and that might be okay. But this video is just to make you aware that even though these look the same, right, especially in a CAD context, right, it's like, why do they have all these options, right? It means the same thing. They have a different tolerance stack up consequence. at the end. Let me show you the dimension origin symbol real quick. So here's how we would show that with dimension, so an angle and a linear dimension. With the dimension origin, we're just going to replace one of the arrows with a circle. And that's telling us to measure from this side. We do the same thing here, right? Dimension origin symbol. And if you see several of the figures in Y14.5-2018, these dimension origin symbols crop up where they did not in previous versions of the standard, although the symbol has been around for a while. So this is one way to do it, but this, with your angle here, only gets you the knowledge that one side is 0.9463, which again is significantly smaller than 0.98, which is, when you first look at it, maybe what you think the tolerance on both should be. So that's it for this video. If you enjoyed it, please like and subscribe. Leave a comment down below.